Yeah, geometric.
Yeah, you're proving something, a geometrical statement.
Yeah.
I didn't mean like you're proving using geometry.
Okay.
So
This way?
yeah, like this, yeah. Okay, sorry, Monica, which question is this? 6. Now, good news. It's if and only if. Do you see that in the question? That means you have to prove it both ways. That's what if and only if means. Yeah? Do you know this expression, if and only if? No, it doesn't actually. If and only if means this symbol. Do you not know this?
Yeah.
It does. Guarantee it. $1 million. $1 million American dollars too. I know.
Because if they tell you the class is the same, if and only if they say the same. Only if they say the same, then class is the same. Okay,
It does make
it's the statement.
if and only if.
It's only when the brain says.
You can think about it like this, Monica. If and only if is like if slash only if. So you can say A if B and A only if B. So A if B means if you have B, it would give you A, and A. Oh well, I guess it doesn't work to write it that way. No, I get what you're saying, but in maths the expression if and only if means both directions. And in fact it can be abbreviated like this. IFF. Have you seen this one?
No. Double F.
Double F, yeah. Okay, let's have a look. So let's start off in the direction where we know the dot is 0. Okay, so that means, oh, and we also know that they're not 0. What I mean is the vector A and B are not 0, 0, 0. So, I won't bother writing that. So if that is true, then that means this would be true as well. As long as A and B magnitudes are not 0. But if that is true, then this is true. Because cos theta is the same as that. Yeah. Now if that's true, it means theta is 90 or 270. But in both cases, if they're 90 degrees apart, or if they're 270 degrees apart, in both cases they form right angles. So that means that A is perpendicular to B. Now, that was the one direction. Now we have to go in the other direction. So that was what you might call this direction. Now we have to go this direction. Go on.
So you have to expand when the A is
Here? Oh no. This is everything. Now, let's go backwards. So I know that theta equals 90. So that means cos theta equals 0. So that means A dot B over magnitude A magnitude B is 0. Which, as long as these aren't 0, which they're not, I can say A dot B must be 0 then. So we have the if and only if, meaning if their dot is 0, they're right angles. If they're right angles, then their dot is 0. We can go both directions. Hang in there, Lee.
Do you have graph?
No, we'll finish a little sooner, okay?
Yeah, that's what.
Why are you so tired? What time did you sleep at?
Today is Monday.
Monday.
And because of summer block.
Somewhere.
1 hour early.
Yeah.
It's not today,
Time change.
Today. It's not
Yeah,
today.
yesterday, which means last night you had 1 hour less sleep.
No, last night, Sunday night. I mean, Saturday to Sunday.
Yeah,
It's
but
not,
you should still feel the effect one day later.
Okay.
It's not like your body has suddenly adjusted to the new sleeping schedule. Do you know what I mean?
But it's only 1 hour and I haven't slept either.
Okay, whatever.
Maybe should be changing.
It's different because 8 I sleep at home and 9 I'm at school. Because it delay 1 hour in the winter on,
Yeah, by putting the clock forward 1 hour,
yeah.
it means that you get 1 hour less sleep that night.
That's nice.
Yeah, but it means that there'll be now tonight, when you're going home, you'll notice that it'll be sunnier. It would seem like sunset is later.
Oh yeah.
Okay, we have 1 less hour.
We have one
Yeah.
more hour.
No, one less hour. You slept for 1 less hour Saturday night.
Does it change the clock? No.
Was that not changed? Oh, someone changed that.
Someone changed that.
I don't know who changed it. Someone changed it. It must have been whoever had class at 9 o'clock.
No, that clock is no individual variable here.
It changed by itself?
I connect the Wi-Fi.
Oh yeah, that's a Wi-Fi analog clock, yeah.
Really?
Yeah. No. Alright, continue. It's one of those expensive clocks that are made to look cheap, you know? Like my phone.
No,
Yeah.
that's just shit.
Oh no, you're mistaken. Okay, so the last thing we want to have a look at this morning is the practical problems. That is, using vectors to help sort of solving physics problems. So here's an example here. We've got a road, and what is quite common in physics is you can use vectors to describe the motion. So like if this is a road or a field or whatever it is, maybe you have I don't know, a car heading this way, or a plane or something like that. So if you think about it, if we call this like the origin, then we can have these vectors which point to the path here. And maybe over here there's some kind of tower. Yes, some kind of tower. And maybe you would like to know what is the shortest distance between the tower and the path of whatever's the plane. We'll say this is an airplane, maybe. Something like that, it doesn't matter. So I need to give you two things. I have to tell you where the tower is, so let me just say it's at -1, 1. We'll make this 2 dimensions, although it's the same if it's 3 dimensions. And we'll make this plane be, let's see, 40, no. We'll say 3 plus 4t and 5t or something like that. Yeah. And no, actually I need it to be getting smaller, don't I? Sorry. 3 minus 4t and 5t. Yeah, we'll just make that a minus. Okay. Now, I want to know the shortest distance here. So let me call this point here or, and I'll call this one here A. Can you give me a vector that is on this line? Nearly -4. We don't actually need the t. 5. So what is special about A or? Well, A or, if it's the shortest distance, I'll just call this vector here B. That should be perpendicular to B, shouldn't it? Yeah? And what should that equal if they're perpendicular? 0. Alright, let's calculate. So that would be or minus A dot B equals 0. So what's or minus A? Or minus A, that would be 4 minus 4t, 5t minus 1, I think. Yeah, isn't it? Yeah. Dot B should equal 0. Alright. Minus 16 plus 16t plus 25t minus 5 should equal 0. Right, so what do we get for t? 25, 35, 41t? 21. So t is 21 over 41. And you realise, oh, I'm nearly done. Because to finish, to get this distance here, let me just call this distance d or something. This distance d, that will equal the magnitude of AR, which will equal the magnitude of R minus A. Yeah? Which will equal the magnitude of 4 minus 4t over 5t minus 1. But we know what the t is. So that's equal to the magnitude of 4 minus 4t. Now that's 41. 20, 40, 84 over 41. And then this is 5t. That's 105 over 41 minus 1. Whatever that is. So the answer will be square root 4 minus 84 over 41 squared plus 105 over 41 minus 1 squared. That's the shortest distance. It should be quite small enough. You're typing that in, Monica? Thank you. Thank you. Huh? Yeah, I never put in units. Let's make these kilometers. Yeah?
Teacher.
Yes.
Why is point B minus 4, 5?
Why is what now with the what?
Why is point B equal to minus 4, 5? I mean, I thought...
No, direction B. I'm not saying B is at minus 4, 5. I'm saying vector B is minus 4, 5. The line is pointing... Actually, I drew my line stupid.
Why?
Because if it's minus 4, 5, it should be pointing left and down, not right and down.
Oh.
No, sorry.
Right.
I have it way off.
4 minus
Minus
5.
4b is this way.
Yeah.
Oh, okay. Actually, so I just drew my b pointing the wrong way, which doesn't actually change anything. So that's vector b. Vector b is pointing this way along the line.
So 3 is the shortest distance of B.
3?
Yeah. What does that 3 mean? Or it means nothing.
What 3?
3, the equation 3 minus 4t. The constant 3.
Yes.
Does it mean anything?
It does. If you put the t as 0,
Yeah.
you get 3, 0.
Yeah.
It's just a point on the line. The tree doesn't really mean anything by itself because you can write this as 3, 0
Yeah.
plus t times minus 4, 5. So this is a point on the line and this is the direction the line is pointing. So this is a vector. This vector points to somewhere on the line and this is a vector and this points along the line.
Okay.
The 3, 0 only became important at the end when you had to sub in a value of t. Because obviously the tree should matter when getting a distance here. Anything else? Anything else?
Oh yeah. What about R? What is R?
What?
R is the point.
R is on the line, and it's the place that is closest to A.
Okay.
Is it okay?
Oh, what's the formula for R?
You know it, we did this in class, A plus TAB. And this, I give it to you.
Okay.
And I give you this.
Okay.
You see?
Can we just use B? They are the same.
What do you mean, can't we use B? I did use B.
Oh, yeah. Oh, okay. Yeah.
Anything else, Lee?
Nothing.
No. I think that's really actually is the only type of problem I can think of when it comes to practical. Oh, sorry. Thank you. I got it. It's under control. Yeah. Basically, I just imagined 6 different ways to ask you how to do this question. For example, in question 1, actually I should say, sorry, what I didn't say is, how can we interpret what this means? Guys, can we look up? Sean, Jerry, look up here. So I gave you this at the beginning, but how can we interpret it? Well, let's try this. If I make t is 0, then what are we left with?
3-0.
This is where the plane starts its journey. Now, if I put t is 1, I get 3 minus 4, 0 plus 5, yeah?
Yeah.
Which is minus 1, 5. So it starts at 3, 0, and then it finishes here at minus 4, 5 after 1 unit. So in other words, this is like a position, and this is like a velocity, and so this t is actually like a time.
Why? Why is this value?
Because every time this moves up a unit, this much of a change is caused in its position. When the t is 0, I have only this. Yeah? So this is where it begins. And every time a t increases in value, I change it by this much. That's what a speed is. You know, if I said the speed is 5 meters per second, that means for every unit of time, I increase by 5. So, it's the same with vectors. For every increase in the t, I make this much of a change. So this must be like a velocity, and this must be like a position. So, in other words, I could make the question a little bit trickier by telling you a car starts at 2, 3 and moves with, let's say, a velocity of 1, 2 meters per second. So what would be its position at time t? Its position would be 2, 3 plus t times 1, 2. And what would be the units for this answer actually? It'd be meters. Because this was meters, this was seconds, and this was meters per second. So in my last question, when I did this, I actually know what this t here means. This is the time for the plane and the tower to be closest together. It'll take about half an hour, because all my units were kilometers per hour, kilometers. Actually, no, that's stupid. It can't be a plane. No plane goes at 5 kilometers per hour. We'll make it a hot air balloon. Or a boat. Whatever you want. Okay, is this okay, this idea here? Is okay, yeah? Yeah, it's okay? Alright, the only question that's a bit different is the last one. So if you wanted to try something interesting, you could do the first and the last.
Sure.
Yeah. Now make it good, Lee. Make it good, because I'm very tired.
So if the
Yeah.
question mentioned 30 ms,
Yeah?
what is the value for S and what is the value for Y?
If it says what?
30 ms.
If I said what? 30 ms?
The speed.
The speed?
Yeah.
Is that one of my questions?
Yeah.
Read it.
I haven't read it. 2,100 meters apart from the source road, one car is moving at a constant speed of 10 ms, while the other is moving at a constant of...
Yeah, so I only gave you the speed, but because I tell you it's a crossroad, you know, one of them is heading 30 east and the other one is heading 20 south or whatever. You can write them as like 30i and minus 20j. You'll have to draw a picture to figure out what to make the vectors. Do you get what I'm saying? So like, here's the crossroads.
Yep.
If there's one car heading here at 30 and this one is heading down at 10,
Yep.
then this one here, its vector or will be wherever it starts plus t times its speed.
Yeah, the thing is, how do we put in the speed?
Well, if it's minus 30 to the east, it would be like this, t times minus 30, 0. And this one here would be t times 0 minus 10 as the velocity part. Yeah.
What about like the previous question minus 4, 5? What does that mean? What is the speed?
Oh, you would have to get the magnitude. So whatever, 16, square root 16 plus 25, that would be the speed.
Okay.
But you know this from physics when we did projectiles, that if you have two components, the speed is the hypotenuse.
It doesn't affect each other, right?
Of course it does. If these are different, then this will be different. This is called a triangle.
Okay.
And if you change these lengths, you change this length. Let me write this down for you. Triangle. Don't mix that up with angel. That's three angels. Not to be confused with triangle, okay? That catches a lot of students out in the exam. And then they get to the end of the question, they realise, oh no, I did this using three angels. My answer's totally different now.
You're not serious, right?
Haven't I? I'm also very tired. Okay, can I close this, Lee?
Yeah.
Yep.